To create the simulated wind, I'm going to create a brand new ice tree with which to hold some scene data. One of the first things you need to understand when working with scene elements that aren't particle or deformation related is that you have to unlock XSI's kinematics variable. Kinematics are currently unsupported with XSI, but they work very well. It also helps to understand the ice system a little bit better when you do have access to kinematics, things that we work with on a daily basis. In this case, if I hit play and I move the MT wind vector, if you have a look at the Explorer, this wind icon was built when we created the first set of springs, and the springs simply just point towards this wind vector. So if we could take advantage of the position of that vector and somehow use it to drive the wind attribute of each particle, we could use some sort of a turbulence field to create the overlapping effect. If I look on each spring, the wind attribute is something that I could possibly tap into. If I have a look under my tree root parent null, each spring object holds a display info parameter, and the display info parameter is the wind one that I was manipulating over here. So I'm going to set that in an ice graph by getting a brand new point cloud. Again, we'll make an empty one. I'll call this simply wind effect. And the reason I'm not adding a new series of ports to the leaf point cloud is because I want a non-simulated ice tree for this effect. I don't want the results to be based on the previous frame. We already have a simulated effect with Helge's MindThink system, the spring system. So I'm going to create an ice tree on my wind effect point cloud, and I want to set some data. So I'm going to pull in a set data node, and set data nodes are always allowing you to point to referenced objects. So I can pick an object whose data I want to set, and I want to go onto the spring parent object. In fact, all of the spring parent 1, they all contain a spring wind attribute that can be set. So if I set that for a few of them and randomize the values, I should be able to get the tree moving the way I want. So I'll double click and I'm going to add 2 more ports here. Just work with 3 values for now. You'll get the idea once I've done this a few times. Of course I'm going to work with the base of the tree. Well, actually, you know, I could probably leave the base of the tree in this case, as this is going to act as a bit of an anchor for the tree. So maybe I'll even start with this second one here. So this is MT spring parent 1. So I'll explore for that. Point cloud. Let's look under my tree root branch. Spring parent 1. I'm going to go and access its wind parameter. So its wind currently is set to 0.45 as a strength. I'll go in and find some more of these. I'll go and find spring parent 2, its wind attribute. Actually do some copy and pasting here. It's a very quick way of setting this up. Just change these names, and you can notice how the set data is being incremented in the compound set data node down below. I'll do one more. So we have spring 4. So I'm just not affecting this base one here. Okay, I'll plug the set data output into the ice tree's port 1 input to terminate it. And what I'm going to use to set this wind effect is the global position of the wind icon. At the moment, if I move the wind icon, like I said, we get the vector acting as a directional constraint or an aim constraint for the spring. And we have the strength of the wind per spring. If we look for a node that gives us access to turbulence, I'm going to pull in a basic math node. So we have a basic turbulence, and we can use the position of an object to vary some turbulence over time. One of the other things that's kind of interesting is you can even hack into the turbulized value by range nodes and manipulate those. So let's see, if I wanted to go in and control the range using anything but particles, if you actually explore the turbulized value by range, it's actually using the particle position as a basis for manipulating the turbulence position. So if I replace particle position with the wind icon's global position, I'll be able to have this compound work for kinematics. So I'll pull a get data into the graph. I'll grab my object here. I'll put it in and explore for my global position. I'll disconnect the particle position and replace it with the wind's global position. There we go. And I'll close that down. That's all we really need to do, is just replace the items, and now this turbulized range will work for the spring. So if I actually move the node out of the way now, I should be able to go and work some of these values. So we can set to an animated value, and already I'm getting movement through my spring. If I hook this up to the other wind icons, I'm already getting some movement for my tree. I can control the min-max, I can control the amount of movement, and it's a really nice way of just being able to offset the branches slightly during animation while the leaves are moving to give yourselves a more believable integration of both tree and leaf.